Hello guys, welcome back to Maison African Motifs. This time we are going to be focusing on our analytical geometry. This is an exam question that we have, and we want to see how exactly are we supposed to attempt or to answer such typical questions of this lecture on our analytical geometry for mathematics grade 10. So this is question number 3. We are given question number 3. In the diagram below, we have got the points A, B, and C, which we are given, and their coordinates in that case. And these are the vertices of a triangle, ABC, and we're given AD is drawn such that the point D is minus 2K. This line AD is a midpoint of BC, right? So we're given that this is the midpoint. The point that we are seeing here, D, is representing the midpoint of what? Of BC. Take note, this is your point B, this is your point C. So in between this line, it means we've got a midpoint that is, we've got equal distance from B to D, from D to C. We've got equal distance. That's why we see these two here to show that we've got equal distance. All right. So anyways, let us check our questions and see, but I'm just going to write the midpoint so that we'll be able to remember about the point D. All right, so the first part of our question here, 3.1, was to determine the gradient of BC. All right, the gradient of BC. Remember, the gradient is simply the change in y over the change in x. That is the increase or the decrease in y over increase or decrease in x. So when you're asked to calculate the gradient of BC, all right, we can use this sign. We can use the letter M for the gradient, okay? The small letter M for gradient. So this is the gradient of line BC. So just gonna write line BC like this, okay? So for the formula, there you can write the way that you want, but it's just the change in y over the change in x. What am I trying to say? It simply means y2 minus y1 over x2 minus x1. So you can even take it the way that you want. You can take it as y1 minus y2 over x1 minus x2, as long you understand that you are simply subtracting the y values corresponding to each other and the x values corresponding to each other. All right, so if you refer, this is our point B, remember, this is our point B minus h2, that's our point B, which is minus h2, and the point C here, which is for what? Which is for 6. And according to our coordinates, the point is made up of x and y. That is what makes or what builds up a point. It's x followed by y. So if you choose to say this is your first point, this is your second point, therefore you are going to use this as y2, that is the y value on the second point, which is 6, minus the y value on the first point, which is the y value on the first point is 2. All right, everything over the x value on the second point, x2, which is the x value on the second point, that is 4, minus the x value on the first point, which is on the first point, our x value is minus 8. So this is going to be given as a minus 8 like this, okay? Which you can just simplify on your calculator, this gradient. Okay, so that is how you can actually attempt these questions. All right, so let us just simplify this on our calculator. That's 6 minus 2. So you're going to subtract 6 minus 2 over 4 minus minus gives us a plus. But you can even just write it as it is 4 minus, just open a bracket, then that's a minus 8 like this. Okay, so this is going to give us 1 over 3. Okay, so that is going to give us 1 over 3. So this is the gradient of what? The gradient of the line BC. We have the gradient. So like I said, even if you used it the other way, the y value on this point minus the y value on this point is the same. If you used 2 minus 6. You're going to have the same thing. The y value here is 2 minus the y. What is important is that you are subtracting corresponding. If you start with this point for the y values, also do so for the x. When you're subtracting, you're going to start with the x of this point, which is minus 8 and minus 4. So it's going to be minus 8 minus 4. So if you start with this point on the y value, you must also start with the x value when you are in the denominator. Do not interchange to say you use the y value as your starting point here. On the x value, you start with another point. You are supposed to use one point as your starting point to say this is my point 1, this is my point 2, and apply your formula. Okay, so that is 3.1. Then 3.2, it was to calculate the length of BC, the length. Moment to talk about the length, you think about what? You think about the distance. So if you think about the distance, that means you're simply talking about the distance formula. In this case, we want to calculate the length of BC, which is the line that we've been calculating its gradient. Now we want to calculate its length. All right, let us just put it this way. Remember that the length is simply taken from the distance, okay? So that's 3.2. So the length of BC from our distance formula, we're going to have our formula as x1 minus x2 squared, okay? So this is going to be x1 minus x2 squared plus, all right? So here we're going to have plus y1 minus y2 squared. Okay, so this also can be given as x2 minus x1 squared, okay? y2 minus y1 squared. What is important is that you are simply subtracting the x values, you square them. You subtract the y values, you square them. That is the whole idea of this question, all right? So that means BC is going to be the square root of, let us take x1. We said this is our first point. So meaning to say our x1 from the first point is -8, all right? x2, which is 4, the x value on second point, which is 4. So it's -8 minus 4. Okay, so this is going to be -8 minus 4 squared. -8 minus 4 squared. Remember, x1 minus x2 squared. Plus, in this case, we are going to have y1 minus y2. The y value on the first point minus the y value from the second point. So this is what you're going to have. The y value from our first point is 2, right? The y value from our second point is 6. So it's going to be 2 minus 6. All right, so that is the difference that we have. 2 minus 6 to the exponent of what? To the exponent of 2. There we have our distance, which is the length of BC. That is how you're supposed to determine this. So that means our BC at the end, like I said, we can also just use the calculator there at once. Okay, this is just a part that they've got 2 marks. So substitute is on your calculator. That is going to be the square root of, just open a bracket. This is -8 minus 4. Okay, -8 minus 4. So this is going to be -8 minus 4 like this. Then you square the bracket. Okay, plus you open the bracket 2 minus 6. So you're going to have 2 minus 6 like this. You square that bracket. This is going to give us 4 square root of 10. So we are going to obtain 4 the square root of 10. So this is the length. The length you can just write measured in what? In units. We do not know the units exactly that we are given, not meters, not centimeters, just write the units. If you want to write it as a decimal, you can change this, okay? Depending with the question that you're given, sometimes they ask you to round off to 2 decimal places or to 3 decimal places. All right, let's say you want to round off to 2 decimal places. In this case, you're gonna just shift, go to the mode, fix this on 6 here to 2 decimal places, you press 2. All right, so this is going to give us 12.5 to 2 decimal places, or you're gonna have this as 12.65. Okay, 12.65. That is if you want to write it as a decimal, and also depending with the instruction that you're given, if you're given to 3 decimal places, 2 decimal places, whatever that you're given. This one you are not given. a particular instruction, right? So I'm just answering on a way that you're not given, then you want to round off to 2 decimal places. But if you want, depending with the question that you're given, all right, you can just leave your answer like this in said form. Remember, this format is referred to as the said form from our sets, right? The said form, you know, this one of writing under a number under the square root like that. So it's a format that you can actually leave your answer as, which is fine, okay? Let's check the other part, which is 3.3. Determine the value of k. So we want the value of k in this case here. All right, remember what we were told about the point D, that the point D is the midpoint of BC. It is the midpoint of BC. So if it is the midpoint of BC, what does it mean? We know that from our midpoint concept, this is how you calculate your midpoint. All right, remember how you calculate your midpoint. The midpoint of any line that you're given, all right, between 2 points, you add the x values, x1 plus x2 over 2. You add the y values, y1 plus y2 over 2 like this. This is how you calculate the midpoint of any point, of any given line. So if you check here, already they calculated for you because you are already given the point D as minus 2k. This is where we have our point D minus 2k. So already they calculated for you the x value, this one, the minus 2. They already calculated for you. You added these two and divided. So meaning to say they just added minus 8 and 4 together and divided by 2. Remember I said x1 plus x2. So if we add minus 8, which is our x1, plus our x2, which is 4, over 2 like this, you are going to obtain minus 2. All right, so let us just do this on our calculator and see what I'm trying to say. So this one, if you just put this on a fraction, that's minus 8 plus 4, minus 8 plus 4 like this, all right, over 2. All right, so this is over 2 like this. So, okay, let me just change my calculator back to the normal mode. So it's 8, then you press 2, it's back to the normal mode. So you get a negative what? A negative 2 in that case. Okay, so this is what I'm trying to say. They already calculated this value for you. So it's not our worry because already that value is there. Our worry is to have the value of k, this one, the value of k. K represents the y values. This is the x value, this is the y value. So to obtain k, which is the y value at the point D, we simply need this part here because that is the one for the y values. We simply have to add y1 plus y2 over 2 at the midpoint. So that means we can obtain the point k. All right, so that's 3.3. The point k, we can simply take it from what? Y1 plus y2 over 2 from this. Just like how we calculated this minus 2, x1 plus x2 over 2. So that is what we simply needed in this case. So your k was going to be the y value at 0.1, which is 2, all right, plus the y value at the second point, which is 6. Then we divide everything by 2. So this was going to give you a 4, okay, 2 plus 6, that's 8 over 2, which is a 4. So that means the k in this case is going to give us a 4. That is what the question was all about. Okay, so now we've got a complete point in this case, which is minus 2 what? Minus 2, 4. We might need to use this point later on. So let's just indicate like that. Okay, no problem. So this is how you could have calculated. Or you could have just calculated the midpoint as usual. You add your x and your y values, but k represents the y value. So you take the value corresponding what? To the y value. All right. Now they're saying on 3.4, is line AD perpendicular to BC? Show all your calculations. All right. It's a question, this one. They're asking you. So if you're asked, you have to prove that is it true or not. Is it perpendicular or not? Okay, we want to prove that, or we're asked that, are these two lines perpendicular? AD and BC. All right, let us just have it this way. AD, we want to focus on line AD and BC. I think we talked about this before, the part of AD. All right, let me just write it this way. This is 3.4. All right, so the question that we have here is to prove, or we are asked that, is AD perpendicular to BC? Is it perpendicular? Okay, it's a yes or no, but we are supposed to do this by calculation. Our yes or no is supposed to come from calculations. You don't just say yes or no. By just looking on the diagram, you say, I know they are not, or they are. No. What is it that we know about perpendicular lines? In terms of their gradients, that is what we know. The product of the two gradients, the product of the gradient of AD and the line BC should give us a -1 if two lines are perpendicular. So this is a condition to consider, a condition that you need to understand for perpendicular lines. If they are parallel, they have got the same gradient, but for perpendicular lines, all right, for perpendicular lines, the product of their gradients should give us what? -1. So let's prove that. We have the gradient of BC. We calculated this before. BC here, remember that was our first question. The gradient of BC was 1/3. Okay, so we're going to take that. The gradient of BC, we already have this. The gradient of BC, all right, the gradient of BC, we got 1/3. But we do not have the gradient of AD. This one we have, but we do not have the gradient of AD. So we are going to calculate the gradient of AD from the given points, because remember, we calculated the point, the value of K at point D, which is 4. So now we have the point D here, our line AD. We can calculate the gradient. All right, so let's calculate our gradient of AD. All right, remember, this is our point A, which is -3, 7. All right, let's just make it clear. And this is our point D, which is -2, 4. All right, so you're going to calculate the gradient of the line AD. Remember, I said the gradient is the change in Y over the change in X. All right, so if you use the Y values, I don't know how you're going to use them, but just have to subtract the Y values. Okay, so if I use this way to say it's going to be 7 minus, I have to subtract the Y value here. All right, which is 7 minus 4. All right, so that's 7 minus 4. Since I started with this point, subtracting this, I'm supposed to also do the same thing on the X values. On the X values, I'm going to start here. So it's -3 minus the X value here. So it's going to be -3 minus the X value on this other point D, which is -2. So you're just going to open a bracket for that, okay? So as we can see, if we simplify, this is same as 7 minus 4, 7 minus 4, which is actually 3 over -3 minus, that's a plus here. Here is going to be a plus, -3 plus 2. Okay, -3 plus 2, which is a -1. So this is going to give us a -1 in this case, and this is going to give us -3. Okay, let us just prove on our calculator by just finding everything at once. Okay, so this is it here. We're going to have our fraction 7 minus 4, 7 minus 4 over -3. So this is -3 minus, we subtract -2, just open a bracket for that. Okay, so this is -3. All right, so we have the gradient of BC. We have the gradient of what? Of BC. So let's multiply and see if this part is going to be satisfied that we've been talking about the perpendicular lines. If they are perpendicular, we are supposed to get a -1. So you're going to multiply the gradient of AD, the gradient of AD times the gradient of what? of BC, which is equal to the gradient of AD. This is the gradient of AD that we calculated here. We got what? -3 multiplied to the gradient of BC. This is the gradient of BC that we calculated before, which is 1/3. So as you can see, guys, if you multiply -3 times 1/3, we get what? A -1. This gives us a -1. So that means that these two lines, the perpendicular, it can only happen from perpendicular lines that the product of the two gradients gives us a -1. This is only when the lines are perpendicular. If they are parallel, they have got the same gradient if they are parallel. But these ones, they give us a product of -1. So therefore, we are saying AD is perpendicular to what? Is perpendicular to BC, which is true. Okay, AD is truly perpendicular to what? To BC, because their product, the product of their gradients gives us what? Gives us a -1. All right, so that was it, guys, about this particular question. All right, just needed to be very, very careful in your answering. How you attempt your questions is very, very important. The way that you attempt your questions, know about your midpoint, know about your gradient, calculating the length, which is the distance. And sometimes they can even ask you for area or perimeter. You just apply the distance formula to calculate the length of the given sides of the shape that they want you to use to calculate the perimeter or the area. So we shall see questions of that nature in our revisions.